So let's talk about these termite results for just a second. Um, so one of the things, and I want to just kind of reiterate now that we've gone through a week of this course, I want to reiterate kind of how to attack the course. Um, Keep in mind that you're supposed to be doing this yourself, right? This course is set up for students to do the work themselves. Your teacher is supposed to help you with that work, but fundamentally the work comes from the course. So you should watch all the videos that are associated with the course and don't expect your teacher to tell you everything you need to know. This is supposed to be in its original shape. The course is supposed to be an online course that you're supposed to be doing on your own. So having said that, when you get into the course, make sure you listen to the walkthrough. Make sure that'll tell you everything you need to do for the week. Then for Bio 113, the key item you need to look at every week, the basically the thing that drives the whole unit, is the lab handout. So start with the lab handout. The lab handout has two parts to it. It's got a lecture part and it's got a lab part to it. The to know part, that's the lecture part. The to see and to do part, that's the lab part. In the case of the scientific method, your lecture part has to do with the termite social order and the scientific method. Your lab part has to do with the experiment you're doing. So now let's look at how the assignments go together with this lecture and the lab part. So looking at the folder, you've got the overview, then you've got the know, to see, to do. To know, that's the lecture. Watch the lecture. There's a PowerPoint that goes along with it that you have access to. And this lecture quiz goes with this lecture assignment. So watch this, then do the quiz. This information and this information comes from the lab handout. So we're going back to the lab handout. That's where it all comes from. The to see, to do, you're starting with the lab handout. You're looking at the demonstration. Remember this all of this was initially a face-to-face class. So we translated it into online. So watch the demonstration, because sometimes the translation into online is not trivial. So watch the demonstration. The demonstration then um, basically takes you through things that the lab handout tells you were supposed to do. And the handout question set then helps you answer these questions in the lab handout. The Labster is the other to do part. It's independent. So you're doing Labster, you're going to get graded for Labster. Labster questions do not come into the exams. The exams are entirely coming from the lecture material and the handout question sets. Labster does not come in. So let's look at the termite, the lab handout of the termite question set. So the first thing you were supposed to do is you make observations, right? And I put this on here. So you're watching videos. Normally you'd be watching termites, but you were watching videos of other students that took images of termites. Now, students tend to film things that are interesting. So you actually got more films of termites on pens than you did with termites on markers, because termites don't follow markers. They follow pens. And so students tend to film the pens. And one of the things you should have noticed here, one of the observations hopefully, was that they tend to follow pens. Whether there's a color difference, we'd have to check out, but they tend to follow pens. And so this hypothesis is, I see them following pens, or I see them following red. Now, the other thing here is, when you look at the book and you look at the lab handout, you'll see that the scientific method is described in a slightly different way. What is a hypothesis here, I think the book, the 112 book, would probably call a prediction. Um, those are minor differences. Don't hang yourself up on that. This is why I don't like to have the multiple choice questions. This is exactly the right answer. Understand the concept. Understand what the purpose behind the prediction, the purpose behind the hypothesis is. So um, it must make sense and it must be testable. Testable being the operative term here. All right. So further on into your lab handout, you see these questions. What kind of data will be gathered? A lot of times students in the lab have no idea what to even do there. If you have no idea what to even do, go in the handout question set. Because sometimes if I turn the handout question set if I turn the question into a multiple choice question, you may be able to select the choices as opposed to coming up with them de novo. So the handout question sets sometimes help you answer the questions in the lab handout. Go back to the lab handout, fill the lab handout out. Actually, fill those things in either electronically or by hand. This example of the dependent responding variable, I want you to think about what possible dependent or responding variables are. And I just sent you an announcement that told you the difference between dependent and independent variables. The way I think of it is when you're setting up an experiment, there's certain things that are part of the setup that's independent of the experimental outcome. What's part of the setup, that's your independent variable because it's independent of the outcome. It's part of the input. So I don't care how you remember that, right? If you remember it as part of the input, so that's the independent one, or if you remember it as being independent of the outcome. The dependent is the one you measure. So if you measure the line in centimeters, that's a dependent variable. And note that here, the dependent or responding variable, the dependent is whatever unit you use in the end. You have to have a kind of unit, right? And so a type you have to have a type of unit. And the type of termite, that's not a unit. The time on the line, that's a unit. Because you can say it's 3 seconds, it's 15 seconds. The distance traveled, that's a unit. Because you can say 3 inches, or in scientific terms, 1 centimeter. That kind of thing, right? So that's the difference between the dependent and the independent variables. Now, the experiment itself, I told you I was going to tell you a little bit about the data. You're putting the data into a Google form, and I did this so that in case some of my students struggle with the experiment, I could then use data that I already had gathered from previous classes that helped me, drive home the point. So I know you can't see this. That's an example of the data. I've got like 146 data points at this point from students that they have turned in. And when you're collecting the data, this is something that you may want to, this is sort of what this looks like when you're collecting data. And what you have here is you've got the time on the time on the line with the red pen, first, second, and third trial, the red marker, first, second, and third, black pen, first, second, and third, blue pen, blue marker, green pen, green marker. And when you're looking at these numbers, you see that there is a difference, right? It looks like these are all in the 20s, these are all in the 10s, but this is hard to grasp just looking at the numbers, right? And because it's hard to look at numbers and grasp concepts, we turn numbers into charts. We turn numbers into graphs. So because it's hard to look at the table and understand what's going on, we turn numbers in tables into graphs. Now, before we turn this into graph, we probably should manipulate it a little bit. And so one of the things you tend to do is maybe you'll average these three, right? So that you're dealing with just one number then with rather than three. And so what you end up with when you do that, you average these, and then you make a graph, not a graph, yeah, I guess a graph. Then here's what you see. And that's pretty obvious, right? What the difference is. Given this information, for sake of argument, if you came across this, termites see red, newspaper article, some scientist, some yokel somewhere said that, you just gotta paint your house red to keep your house safe. And then they show you this chart here where they say, look, black marker, blue marker doesn't do anything, green marker, here, red marker, that's what the termites follow. So red color, clearly they follow red color, right? Um, and then, or you see something like this where you're like, yeah, clearly that number is the highest. And there's lots of things wrong with these chart, right? The least of which is the big difference here is clearly between the blue marker and the red and the green and the black, right? That's really where the big difference is. So there really isn't a difference between the red and the green and the black. And there clearly was a manipulation happening in the scale on the left. And you may laugh, but you actually see this sometimes in real charts. When you look at a real chart or a real graph out there in the world, pay attention to what it says on the side, because sometimes we expect these scales to be linear or logarithmic, but oftentimes they're not. So pay attention to where you're trying to be manipulated. And this is similar. This is a pretty standard kind of thing. Like if there's a really big difference somewhere, right? That you shorten it so that these bars don't go through the roof. So that's a pretty standard thing to do. But don't do it to try to manipulate differences, right? Because clearly here it's done to manipulate um, the impression that the difference between these numbers isn't the same. But let's go back. If we're looking at the real numbers, right? This is what the results look like, right? So the markers, they don't matter at all. It's the pens they follow. So the differences between these numbers is negligible. It means nothing at all. And this statement that you can use red paint, that's wrong anyway, right? Because first of all, red doesn't make a difference. And you can't make a blanket statement about paint because you haven't done an experiment with paint. You've done an experiment with a marker in this particular case. So, maybe if you, color your house with a red pen, well, I guess they'll go to the house, right? But if you, so I guess don't color your house in pen. I guess that's the take-home message. Um, and I hope this makes things a little clearer than they were before.